Let's start about the removable singular point in the complex variable. So removable singular point is such a singular point when we put directly the point, we get the undefined result. Let a function f of z equals to sine z by z. If we put z equals to 0, the numerator and denominator both are 0, that is 0 by 0 form, which gives an undefined result. But if we put the singular point as a limit of z tends to 0, then we get a finite result. Such cases are called the removable singular points. If we put directly, this is called f of z, so this is f of 0. For putting z equals to 0 in place of z, we get the undefined result. But if the limit is taken, we get a finite result. So the z equals to 0 is a removable singular point. This can be proved in another way when the series of sine z is taken, that is z minus zq by 3 factorial plus z to the power 5 by 5 factorial whole divided by z. Then we get the 1 minus zq z square by 3 factorial plus z to the power 4 by 5 factorial. In such a way, and by putting the z tends to 0, we get these terms are 0 and the 1 will remain unaltered, and that is we get the result a finite one. So this is the case of the removable singular point. And now we are taking the another case of singularity, that is the essential singularity. In the Lorentz series expansion of a function, if we make the expansion of an arbitrary function, we can write that a0 plus a1 into z plus a2 into z square plus a3 into z cube plus a minus 1 z to the power minus 1, a minus 2 z to the power minus 2 plus dot. So here the terms where the z always exists like a numerator, and if the z exists or its powers exist as a denominator, these are the principal part, and this is the analytic part. If for any point, if for any value of z gives the infinite number of terms in the principal part, then we call that z as essential singular point. We take a function e to the power 1 by z. This is written as 1 plus 1 by z plus 1 by 2 factorial z square plus dot dot dot. So this 1 is only the analytic part, comparing with a0 only. There is no analytic term here. But the remaining terms, all the remaining terms, infinitely are the principal part. And if we put the z equals to 0 in the principal part, this term is infinite, this term is infinite, and this is going up to infinity. So the principal parts are infinite, all the principal parts are infinite. So we get the z equals to 0 for this function f of z equals to e to the power 1 by z is an essential singular point.